Thank you, Lance, for the introduction and for setting the stage for this month's Connections. Hello, everyone. My name is Natarajan, and I'm Senior Director of Knowledge Graphs at Neo4j. I am super excited to be kicking off this event today, where our focus is going to be all on Neo4j knowledge graphs and how they transform businesses. Now, knowledge graphs have been around for a very long time, almost 5 decades, but it's only in the last few years that they've really picked up so much steam, mainly following Google's announcement of their knowledge graph in 2012. And then in 2019, Gartner put knowledge graphs in their hype cycle for emerging technologies. And then, of course, there was no turning back. That was it. Knowledge graphs made it to the center stage, and now they've become the technology du jour. But the question still remains, why knowledge graphs now? They've been around for a very long time, but it's only now that they're beginning to play a big role in technology. Why is that? That's because we're actually watching the convergence of analytics, data science, machine learning, and AI, and they're all pushing the need for knowledge graphs. And knowledge graphs are being pulled along with that momentum because they have the capability to make each of these technologies better, smarter, and most importantly, much, much more predictive. Okay, so this Connections is all about how knowledge graphs help transform businesses, both with data management as well as data analytics. All right, with that, let's get started with some statistics. About a year ago, yes, I believe it was a year ago, a pulse survey was done of 100 tech executives. Here we're talking about CIOs, CTOs, CDOs, and even some CDAOs. And the survey showed that 88% of all these CXOs believe that knowledge graphs would significantly improve their bottom line, whether it was to bridge data silos or to improve AI ML systems or to open up new revenue streams. So that was the Pulse survey. The second and third stats come out of a customer segmentation analysis we did late last year. We found that about 67%, or I'd say about 2/3 of our customer base, has implemented knowledge graphs for various use cases. Shown on the right here are a few of the customers who have successfully implemented Neo4j knowledge graphs. As you can see, these are all large organizations in various verticals using Neo4j knowledge graphs for multiple use cases. Now, more importantly, the second point that came out of the customer segmentation analysis was that all our data science projects started off with a knowledge graph, meaning graph data science is an important part of knowledge graphs and should not be overlooked. Amy Hodler will actually go into much more depth about this in her presentation later today. So make sure you catch that. All right, so that begs the question, what exactly is a knowledge graph? If you Google knowledge graph definitions, you're going to get over 100 responses. And this is not surprising, as knowledge graphs have been around for donkey years, almost half a century. So here's our Neo4j definition of a knowledge graph. It's an interconnected data set enriched with meaning, so we can reason about the underlying data and use it confidently for complex decision-making. Okay, I know there's a lot in this definition, so let's unpack each of the elements that go towards the creation of a knowledge graph. Now, every Neo4j knowledge graph is made up of 3 elements. We have data, we have graph, and we have an organizing principle. So let's walk through each of these elements. The first element is data. There are different types of data. We have structured data. This is the kind that you store in a relational database. We have unstructured data. This includes data like audio, video, text, and much more that you store in a NoSQL data store like MongoDB. And then we have semi-structured data that includes things like CSVs, JSON, XML, and so on and so forth. All right, the second element, and that's graph. When data gets ingested into a property graph store like Neo4j, relationships are added between data points, and they provide the first level of context data. We call this dynamic context. And that's because when you take data and you throw it into a dynamic structure like a graph, you get a structure that's contextually connected to all of its neighbors. And then the neighbors are connected to all their neighbors. So the graph grows richer and richer as new information is added. So context is dynamically being added. Okay, and finally, the third element, an organizing principle, a major type of which is semantics. If you take data in a graph and you add semantics to it, you get a knowledge graph. Semantics adds that second layer of context to graphs. And so knowledge graphs have deep dynamic context. I can't stress the importance of adding this contextual or semantic layer because this is the step where we're making the data smart. Basically, we're driving intelligence into the data so that systems and humans can infer meaning from it. So I have just introduced a new term, semantics. Well, what exactly is semantics? Many of you in the audience may already know what semantics is, but for those of you who don't, semantics basically means meaning, and that confers context to things. There are different types of semantics. Firstly, we have controlled vocabularies, as shown on the top here, and these include things like synonym rings, taxonomies, and ontologies. Let me just go over these very briefly. A synonym ring or list is a list of predefined terms and their synonyms. Okay, a taxonomy is a list of predefined terms and synonyms, and it provides hierarchical relationships. So you see that it's getting slightly more complex as we go further along the arrow. A thesaurus is a list of predefined terms and synonyms, but it's one level higher as it provides hierarchical as well as associative relationships. And finally, we have an ontology, which is a list of predefined classes and properties, and it provides expanded relationships. Now, synonym rings and taxonomies are lightweight, whereas ontologies are heavyweight, meaning they have better inferring power, but they take a long time to build and maintain. So one needs to be cautious if one were to embark on building an ontology. All right, next we have entity resolution and analysis. Entity resolution is all about determining whether records from different data sources represent the same entity. For example, say you have a set of products listed for sale on Amazon, and then you have another set of products listed for sale on Google. These products may have slightly different names, somewhat different descriptions, maybe similar prices, and also they'll definitely have totally different unique identifiers. Now, a human can take a look at these records from these two sources and determine if they refer to the same product or not. But obviously, when you're talking about a million products, this doesn't scale, right? Basically, even with software, this is a non-trivial problem. It really means comparing every entity with every other entity and identifying it as similar or as a duplicate. So let's see where this might be important. In a bank, for example, where you might want to know if there are any clients trying to commit fraud, or if you want to detect if someone is trying to avoid paying taxes, you can use entity resolution to answer these kinds of questions. Okay. Now, yet another type of semantics that's shown here is tagging, categorization, and classification. I'm not going to define these further as we all know what they are. And then finally, we have AI. AI is such a vast topic. It covers everything from machine learning to deep learning to natural language processing and even natural language understanding. Now, in terms of context and knowledge graphs, AI is very important for a use case called knowledge graph completion. This is a process by which missing entities and links are added to knowledge graphs using entity resolution and embeddings. Okay. All right. So why are knowledge graphs so exciting? I mean, I've just given you a ton of information about knowledge graphs. The simple reason is that knowledge graphs lend themselves really well to multiple use cases. Now, shown here is just a sample. These are typically the ones we have seen our customers use, but we have over 40 knowledge graph use cases, and that list is growing. Now, if we had a data spectrum, we could break it down into two different types of use case groups. We have the data management use cases, and then we have the data analytics use cases. Neo4j provides two types of knowledge graphs. We have the actioning knowledge graph and the decisioning knowledge graph. So first, let's talk about the actioning knowledge graph. This is a data management knowledge graph whose aim is to drive action by either providing data assurance or data insight. Let's look at the data assurance knowledge graphs. These focus on data aggregation, validation, and governance, and include examples like data lineage, data provenance, data governance, data compliance, and risk management. On the other hand, if you take a look at data insight knowledge graphs, these go beyond visibility of information, focusing on exploration, deduction, and inference of new knowledge. Examples in this category include X360. Customer 360 is the one we're all familiar with, but we could very well have Patient 360, Product 360, Agent 360, and so on. We also have identity and access management, fraud, AML, root cause analysis, impact analysis, recommendation, and many, many more shown in the second column. Okay. Next, we have decisioning knowledge graphs. These are used for analytics, machine learning, or data science, where the aim is to improve decisions. Examples shown here include churn analysis, what-if analysis, feature engineering, knowledge graph completion, and others. As we can see here, what's important to keep in mind is that most use cases typically start off as actioning knowledge graphs, but then they end up being decisioning knowledge graphs when analytics are involved. That's what these dotted gray arrows signify here. If we think about it, this is not surprising, as data is a continuous spectrum. So people first get insight into their knowledge graphs, and then they start using algorithms, and finally may even venture into graph-based machine learning. That's the typical graph journey we see a lot of our customers take. Just to make this clear, I'm going to use fraud to exemplify this. Fraud identification is a data insight use case, but when you add graph algorithms to it, you can use it to detect fraud, as algorithms allow you to detect similar patterns. You can also use algorithms to extract graph features and use those features to train your machine learning models to predict fraud. So basically what we've done here is we've gone from fraud identification, which is a data insight use case, to fraud detection, which uses graph-based analytics or algorithms, and then to fraud prediction with graph-based machine learning. Okay, so we've actually covered the gamut of use cases across the data spectrum, and that's an important thing to keep in mind. These use cases aren't discrete use cases, but they just follow through across the data spectrum because data is a continuous spectrum. All right, now that we know all about knowledge graphs and the various use cases, let's see what Neo4j product components we would use to build knowledge graphs. Basically, there are 4 products. We have the Neo4j database, or Aura, as the graph data store. We have the Neo4j knowledge graph workbench for data modeling. We have Neo4j graph data science library, and this is our analytics engine. And finally, we have Neo4j Bloom for visual investigation and exploration of data. And here we see how Neo4j knowledge graphs fit into the larger ecosystem. I'm actually going to take you through a data journey a lot of organizations take with knowledge graphs and show you how easily this can be done. I'm going to go from left to right. And so starting from the left, we have the first layer that I like to call the data orchestration layer, as it deals with all the different data types, structured, semi-structured, and unstructured. And then we also have the tools that are needed to extract, transform, and prepare data for ingestion into the graph data store in this layer. For data orchestration, we need ETL and NLP tools. For ETL, we have a number of options, including the Neo4j connector for Apache Spark. This is our new connector. I think we GA'd it sometime late November last year. And then we can also use Hop. And we also see a lot of our customers using their own tools. For NLP, we have APOC. These are Neo4j wrappers around Google, Amazon, and Microsoft natural language APIs. These procedures extract entities, key phrases, categories, and sentiment from text that's stored as node properties. Now, these are all important, but in this layer, I'd also like to point your attention to a tool a cool tool called Semantics, especially as it relates to RDF. Now, Semantics is a plugin that enables the use of RDF and its associated vocabularies like OWL, RDFS, SCOS, and others in Neo4j. As far as we're concerned, we treat RDF as just another data type that needs to get ingested. Okay, so that's the first layer. The second layer is what I'm calling the data catalog layer. This is where data is organized, enriched, and accessed. This is where the semantics, like product taxonomies or ontologies like 5.0 and SNOMED reside. Here also we have all the Neo4j products I had mentioned that are available for building knowledge graphs. Okay, and the third layer is the data consumption layer. And this is all about how data is going to be consumed via the various use cases. And some of these use cases are shown on the right here, and they run the gamut from data management to data analytics use cases. And then they're exposed if need be for further analysis. So you could have further visualization. We have a BI connector that gives access to over 50 BI tools. Shown here are some of them, obviously Tableau. We have TIBCO, Sisense, and many others. We can also expose it to APIs such as GraphQL so that other systems can consume this data. And then finally, expose it to AutoML tools such as KNIME and Dataiku for further ML or machine learning processing. Okay, so you see that the Neo4j Knowledge Graph solution is built on solid products with access to a very rich ecosystem, all the way from ingestion to further processing and finally visualization. Okay, so let's now switch gears and look at knowledge graphs for transformation, because after all, that is the theme of this connections. Now, I always like to look at stats. There was an Adobe survey that was done in 2020 of about 1,000 IT decision makers, and I found that about 37% of them cited data silos as the top challenge facing IT teams today. Okay, now every organization has data in silos. That's a given. I mean, I can't imagine a single organization that does not keep data in silos. And data in silos is not a bad thing. The reason is that one can maintain and control this data and establish governance policies, right? And that's very, very important. But data in silos also often reduce speed to analytics, accuracy of reporting, and even data quality. And we have a speaker today, later this morning, who's going to talk about how you can improve data quality. But the question is, how does one go about bridging data silos? This is where knowledge graphs come into play. The links, the connections, the interconnections, and the context added by knowledge graphs help to link together the variety of structures and the variety of formats across the various data silos in an organization, providing complete visibility. Okay, so knowledge graphs help organizations bridge data silos and use their data assets in a much more, I'd say, agile and connected way without disrupting anything. Okay, so from bridging data silos, we go to building data fabrics. First, a quick definition of a data fabric, and this is a definition that I like. The data fabric is a layer that supports all the data in a company, how the data is managed, how it's described, how it's combined, and how it can universally be accessed. Okay, so a data fabric is composed of a set of capability layers, as we can see on the right here, that transform and abstract data from various sources on their way to the consumer. I always like to think in terms of analogies. So think of this like a value chain of raw materials that are transformed into consumable finished goods throughout a variety of steps. Okay, so knowledge graphs play a very important role here as they provide the backbone for the data fabric. Knowledge graphs describe the relationships between data sources throughout the entire fabric and add an extra layer of context, thereby providing data contextual capabilities as well as contextual intelligence that are used to drive data orchestration and, of course, automation for operations and analytics. That's the topmost layer you see here through a variety of use cases. Now, what's the goal of a data fabric? It's to maximize the value of data and accelerate digital transformation. And who doesn't want digital transformation in this day and age, right? So with that, we come to my final slide. It's not surprising that knowledge graphs are so hot right now. As you can see, they play an important role in bridging data silos and building data fabrics. But it goes way beyond that. So let's take a look at why we say that Neo4j knowledge graphs are transformational. Let's take a holistic look at how knowledge graphs transform data and analytics. We've been talking to CIOs, CDOs, CTOs, and other business leaders in various industries. And they've told us that they're starting to think of their data as a business asset, meaning they're now starting to use data to get better insights, for improved decision-making, and even enhance business performance. Now, to ensure that they get maximum value from their data, business leaders tell us that they're focusing on 3 major areas. They've been told that they need to act as governance gurus for data management and governance of data. They need to act as analytics champions for data analytics, as well as machine learning and AI. And they also have to act as digital innovators for digital transformation and new innovations like data fabric and digital twins. Now, how knowledge graphs help business leaders in these areas is that they function as a non-disruptive insight layer that drives intelligence into connected data to significantly enhance its value. All this without ever changing existing data landscapes or infrastructures. Okay, so that's one reason business leaders are turning to knowledge graphs. The other reason is that knowledge graphs make other technologies better. I alluded to this right at the beginning. But what do I mean here? I'm going to date myself. Some of you may remember the BASF ad from the 90s, and their tagline was very simple. It was basically, we don't make a lot of the products you buy. We make a lot of the products you buy better. Knowledge graphs act in exactly the same way. They make a lot of the technologies better, providing better data management, better predictions, and better innovations. So we're very pleased that we have guest speakers today who will showcase how knowledge graphs have transformed their businesses and use them for better data management, better predictions, and better innovations. So to give you a quick summary, we'll start off with a knowledge graph journey with LPL. Here, I'll actually be sitting down with Mayank Gupta, who's the Senior VP of Technology at LPL, and we'll be talking about their knowledge graph journey. This promises to be very interesting, so please do join us. Next, then, we'll have Dr. Jesus Barraza, who will introduce you to the actioning knowledge graph. And we have Manta and Standard Chartered Bank, who will talk about how they're utilizing Neo4j actioning knowledge graphs for transformational visibility and automation. Following that, we'll have Amy Hodler, who will provide an overview of the decisioning knowledge graph. And we have NASA and DZD, who will showcase their uses of Neo4j decisioning knowledge graph for transformational predictions. And last but not least, we have Jim Weber, who will expand on how knowledge graphs play a role in digital twins. Yes, you heard me correctly. I said digital twins. And we have TCS, who will share with us how they've combined a knowledge graph with a digital twin for transformational innovation. Okay, so very exciting. I will finish off my presentation with some resources. You might want to take a screenshot of this for later use. There are 2 resources I want to point your attention to. First of all, the Knowledge Graph homepage. You see the URL here. And the second is a new white paper entitled From Graphs to Knowledge Graphs, a short journey to unlimited insights. You see the offer pop up right now. Click on the offer and enjoy. All right, that brings me to the end of my presentation. I thank you for joining me. Over to you, Marilee.
Great. Thank you so much, Maya. That was a great session to lay the foundation for what's going to be a really informative and exciting day. So I appreciate your time getting us all lined up for the day. For those in the audience, I just want to remind you that Maya will be back later in the day for the expert panel. So you can save your questions for her for that time. And stay tuned. The next session will be starting in just a few minutes. Thanks so much.
Thank you.